All right, so last time I think I was starting with the waxing gibbous. All right, so when after the full moon, right, so this is when the moon and the sun are 180 degrees apart. The next night afterwards, um, so and by the way, this happens when the full moon occurs. The sun is just setting when the moon rises. All right, so the next night, the moon won't rise. It rises about 50 minutes later each night. All right. So it's all of this is it's always about 50 minutes, roughly 50 minutes later each night. So 50 minutes after sunset, you're going to get what's called the waxing gibbous, or I'm sorry, the waning gibbous. All right. So waning means, so gibbous, of course, more than half of the moon is illuminated, but it's a little, the gibbous part means less, it's less than full. And notice, this time, um, it's the eastern side that is illuminated, right? The entire eastern side, right? And then the next night you get, there's a little bit less, and notice the less part is now on the western side, so it's a little less, and again now it's almost 2 hours after sunset. The moon would rise, and then it gets even less. So roughly a week after um, the full moon, you've gone through the phases of the waning gibbous, right? So the waning means the gibbous, which is more than half of the moon illuminated, is decreasing. It's waning. You're going to get a night where where um, where the it's actually easier to talk about the rising sun, right? So let's say the sun rises, right? Remember, the sun's going to rise in the eastern side. So think about the left hand side of this as being the eastern side. The sun rises, and the moon is halfway between the east and the west. It's like exactly facing south, and so that's what's called the third quarter. All right. Or it actually has another name. It's also called last quarter. You'll sometimes see people refer to this as last quarter. All right. So that's the end of, the end of the waning gibbous. That's you get like one day of this last quarter. Um, and this, then you get into what's called the waning crescent. Okay. So the waning crescent, less than half of the moon is illuminated. The sun has risen, and and you know the eastern side of the moon is illuminated, and this one, when it's the waning crescent, this is the one that you see in the morning. Like if you know it's light outside and you look up and you see the moon, that's the waning crescent part. You can always see, the waning crescent is very noticeable. All right. At any rate, so the moon is getting closer and closer to the sun's location night after night. So it's a waning. It's getting the crescent part, the illuminated side. Of course, notice it's the eastern side, but there's less of it that's illuminated, less and less and less, and then you go back to the new moon, and the whole thing starts all over again. So it roughly takes 29 and a half days to go from new moon to new moon. All right, let's look at that in terms of the moon going around the Earth, right? So the Earth and the moon and the sun are lined up in the sky. That's a new moon. Again, they're not on top of each other. That's a different scenario. And that does happen, but it doesn't happen that often. We'll get into that in just a moment. All right, so the moon and the sun are in the same location in the sky. That's a new moon. All right, and then what happens, of course, is the you get the waxing crescent. So this, sliver of the moon. This is kind of showing you only one part. So remember, this takes about a week. The waxing, you're getting more and more crescent as you approach the first quarter moon. But notice the angle between the sun, the earth, and the moon is now 90 degrees, right? So this, you can kind of think of this first one at new moon. They're at 0 degrees, right? Now 90 degrees, and then the waning gibbous, right? The waxing gibbous. So this is more than half of the moon is illuminated. And it's going to be the western half that's illuminated. And then when they're at 180 degrees apart, right? So the sun is setting and the moon is rising. That's a full moon, and that only happens once a month, roughly a month. I'm using that term loosely. Once in a lunar phase period, which is what we generally call a month, but it's not true. It's not exactly a month. All right, excuse me. And then we go through the waning gibbous phase, right, where less than the full moon. There's the gibbous is more than half of the moon is illuminated, but notice it's the eastern side of the moon. And then, you got about a week or so of that. And then notice the moon, the earth, and the sun are now again at 90 degrees. Again, in this case, you're going to have the eastern side of the moon illuminated. And then, you have the waning crescent, which, like I said before, this is the one that you'll see the moon in the morning. I mean, you can see a little bit of the waning gibbous in the morning too sometimes, but this one's much more common to just look up and see the moon in the morning. You're usually looking at a waning crescent, and of course it's less than half, and it's always the eastern half that's illuminated when it's the waning crescent. And then it returns to new moon again, and the whole thing starts again, and goes through its cycle of phases. All right, so the moon, as I said before, the moon rises about 50 minutes later each day. So it's like I said, it's not exactly a 30-day cycle. It's actually more like 29 and a half days. Let's see. This thing about sidereal. Sidereal is based on what's when you see the word sidereal, that means the sun, based on the stars, not with respect to the sun. It's based on the distant stars. And in fact, you'll sometimes see sidereal time. So that's based on the distant stars. All right, so the new moon aligns with the sun and a star. Let's say after 27.3 days, the moon aligns with the star again, and so that's that's because of course the Earth and the moon are moving around the sun, so that position of where that alignment with a particular star has shifted a little bit. But then after 29 and a half days, the moon is lined back up with the sun. So that's really what a sidereal month is. So it's just not that important, by the way. So the 29 and a half days is the time between phases of the moon. So from when one phase happens to when that phase occurs again. That's all that's important about that. Eclipses. Okay, so let me go through these. So this is of course a solar eclipse. That's when the shadow of the moon is cast onto the Earth, and it's usually some narrow region. It's not the entire Earth, because the moon is much smaller than the Earth. And all right, so here's an example, when just consider this: the moon's shadow is always out there. All right, it's always there. You only get this special alignment, and there's a really good picture of this in the next couple of slides. This alignment, when the moon's shadow is cast onto the Earth, of course, that's what we call a solar eclipse. That occurs very rarely because the moon's orbit around the Earth is actually tilted. That is, if you were to line up the Earth's equator with where the moon is, it's tilted by about 5 degrees. Right? And you'll see that. You'll see that here. And so you actually, so to be in totality, there's been several eclipses that happened lately. There was one big one in 2017, and it crossed South Carolina, and hopefully you got to see that one. And then there was a more recent one in 2024, but that was only a partial eclipse. But it was noticeable, certainly, but it was definitely not a full eclipse. And that the reason that the partial eclipse is not as spectacular is the sun is incredibly bright. All right, so to really see this, let's see. Okay, so this is just the path, just showing you. So these are different types of eclipses. You can have just a partial eclipse of the sun, and so forth. For a lunar eclipse, the Earth's shadow, which again is always there, the moon passes through the Earth's shadow. Now the thing about that is when that happens, some of the light that comes from the sun gets bent by the Earth's atmosphere, because the Earth's atmosphere acts like a lens, and the red light gets bent more than the blue light, so the moon will appear slightly red, and reddish is a good description of it. And so they're showing you that here. What I really wanted to get to before the end of this, so this is here's a good picture. This is what I was looking for. So this is actually the orbit of the moon, right? The orbit of the moon is tilted by about 5 degrees. And so usually, the moon's shadow, which again is always there, the Earth's shadow, which is always there, the moon's shadow is just cast out into space. The Earth's shadow cast out into space. The moon's shadow cast out into space, right? It's only when there is this special alignment, which doesn't happen that often. So in fact, there's only twice a year do you get even the possibility of these eclipses, and they call them eclipse seasons. And so everything has to line up just right for the, you can see that this doesn't, it doesn't line up, exactly. So it's only when the moon passes through the ecliptic. In fact, that's exactly what the term ecliptic comes from. That's the only time that you can have an eclipse is when the moon passes through the ecliptic. Right? And again, that's rare, especially like a solar eclipse. You got to be in the right position on the Earth. Most of the Earth is covered by water, so most of those solar eclipses occur over the oceans. As far as a lunar eclipse, all you have to do is be on the dark side of the Earth. So basically, half the Earth, in fact, even more than half the Earth can see a lunar eclipse, because of course the Earth is rotating, and it usually takes a good number of hours for that. So people can see it